basically, let me start with the problem statement. This is, we're going to write, we're mostly going to focus today on one constructor, and that's it. But I assume it might take quite a while, and I also, at the end, want the feedback of the room. Was it like something you were interested in? Was it like practical, impractical? Was it too hard? Was it too easy? I also have like another metaprogramming talk that I can deliver here at some point. But let's go with this one. This is a real problem. This is not like imaginary that we did in 18, 19, something like that. In TBB, threading building blocks. Somebody might have heard about it. So, but basically this is the library for parallelism and threading and asynchrony, also made by Intel. We are not going to talk like parallelism problems, concurrency problems, not for today, only about like API design. What we have here, we have like some struct which is blocked range. It's not like C++ range, don't mix it up. Basically, this is the way how we, like one of the ways how we can set up the iteration space for our parallel algorithms. For example, parallel for. And we say there is like begin, end, and some grain size. And grain size basically is needed to parallelize some work. That's how we basically divide it. And we say which part of the work we should consider indivisible. And if it's like 1, it makes every single iteration like divisible. Again, it's just to explain you what this interface does. We are going to focus mostly on interface, not on like parallelism problems and how we do that. Important thing that I probably add is we don't have default constructor at all. I mean, in the current interface of TBB. But I'll add it here purposefully because at some point we might skip some code writing and just pretend that it would be here if necessary. If like you want to dig even deeper, I can write more code, but we will figure it out how it goes. So basically, this is one dimension iteration space for parallel algorithms. Clear? Cool. Then we have 2 dimensions, 3 dimensions. And then some customer came to us and say, guys, how about adding 4? We just, okay, maybe at some point we would need to add 5, and then maybe 6, who knows? Let's try to make n-dimensional, to just, try to cover it like for everybody. And, there is some, for at least for 2D, there is some cache efficient algorithm that we apply. For this, it's just going to pretend that it's consists on like 4 or 3, like, or whatever we pass here, 2, 1, even 1, like whatever number of dimensions. But we're going to store it as the array of one-dimensional things. And we have a constructor. I mean, this is probably not the best way to write this constructor, but that's literally what we started from when we try to implement this stuff. And what it does, it basically checks. It basically constructs it from like various number of block range. I mean, of course, this constructor has some problems, and like the first problem is we don't check that the number of arguments match the number that we pass here, basically n, right? And we also don't check that all the types actually here are blocked range, blocked range objects. But I can check it at compile time because it's like template. And the question is like, is anybody in the room like, does anybody in the room not know how to do that? 1?
I can think of 2 different ways to do it.
Yeah, I think maybe 1, because we are not going to use C++ 20.
Okay.
So the reason for that is Actually, I'm going to use C++ 17 for now, but our requirement was C++ 11. And this is our requirement even today. Like TBB minimal version required is C++ 11. I'll write it at C++ 17. At some point, I'll probably switch to 14, not to 11, because I don't really want to use like type, name, blah, 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 sometime trace, dot, column type. I would like to use _t, which does it for me. But in principle, there is no major difference between C++ 11 and C++ 14. So we have one person who doesn't know how to do that. So in principle, what we can do, I'm not going to write... Fine. So basically, we can put some enable if here and check the size of parameter pack. We know it at compile time. And we also can check if all the types in these parameter pack are blocked ranges. By is same, but probably also introducing, like, since we don't have full, I mean, we do have fault expression in C++ 17, but we don't in C++ 11. We probably would need to introduce yet another T, which is like T1, which we're going to use like here, and then just do some metaprogramming and Sphene, like based on that. But that's not the point. The actual problem that I'm going to show is one of our engineers, not me, said, okay, now I have these blocked ranges that I either need to construct upfront, or I would need to, write it right here, probably using some alias, right? We can even try to do this, like using val type, and then just copy it for the sake of simplicity. And then comment everything, and then just use this val type here with the same arguments. And they actually, as I said, like, we are not talking about parallelism, we are not talking about like any parallel stuff. So we just try to construct our blocked range. And that's why I'm just using the iterations like from 1 to 2, which makes no sense. Like the numbers can be like anything. The real code does have some checks, if I remember that correctly, but that's not the point. Wouldn't it be nice to allow the users to write something like this without repeating the type all the time? Sure, if they already have blocked range as the variable on the stack or whatever, they can use it like directly by passing, like I did previously for BR1, for example. But if they don't, if they just won't construct it in place, it's sort of annoying, right, to force them repeating blocked range type, even if they aliased it all the time. This is basically our problem that we're going to solve today. Clear? All right. So what we can try to do is to write this thing. If I'm not mistaken, let's check that it works for this. No, because we need as many as n. And I mean, with some, I mean, we probably made solve it even without Sphene, without enable if. We can just put static assert and say that size of this is equal to n. But the point is, like, if we just say t, it's going to be 1. And our blocked range nd is going to be useless. That's why we need some sort of parameter pack. This doesn't work. And honestly, I cannot explain you why. This just C++ says that it's not deducible context. So it does not know how to infer these types from these arguments. And for basically this construction, which I'm gonna refer going forward as the brace init list, there are several contexts where it can be deduced to something.
If you have a blocked range constructor that took a initializer list, would that solve that?
We are going exactly here. Initializer list is one of the contexts. And this is actually the next step in my talk. Let's try to use it. First of all, if we do initializer list like this, we probably need to comment, this part and put some okay, we initializer list, it's third, first of all, then probably, I think we don't need any include. Initializer list. Yeah, so yeah, any help during my talk is appreciated, and here we're going to uncomment our default constructor. So we do have that. It basically deduced, but now we have several initializer lists, actually like 3 of them, and each of those consists of just ints, right? So I mean, I can even do this trick, maybe including EOStream to see some output as well. Pretty function. And then including EOStream. We should probably be able to see it that we have with t's as int. That's why we have initializer lists int here. How are we going to basically construct the blocked range, I mean the array of blocked ranges from these values? I personally have no idea. Especially keeping in mind that it's not like default constructible and then initialize, assignable by every single, separately assignable begin, separately assignable end, whatever. You are not lost, I hope.
Not yet.
Not yet.
Not yet, but I don't have any initializer.
Yes, I also. That's why we just skip this option. This doesn't work. We can.
That initializer list constructor to block range. I wouldn't recommend it, but you could.
But that's exactly the next step. And this time we're going to use T. And I think it works, except 2 things. Again, we can make it work because now we have initializer list of blocked ranges, like one-dimensional. In principle, this is the collection of blocked ranges. And we can say that it's something that we need, right? But there are 2 problems. First of all, we don't want our blocked range to be default constructible. This is by design. All the types that blocked range can work with, and I think it's like iterators and just integers. All those are default constructible and assignable, maybe not, input iterator from C++20, not necessarily, but who cares? We are talking about API for parallelism. Nobody cares about input iterators in parallel world. So the interesting thing here is not only that. Okay, we can say, okay, we don't know how to solve this problem. We are going to relax it for our users. There is a bigger problem. Can anybody guess? What?
Expanding the initializer list into the array.
How what?
I was thinking about initializing the array.
Yeah, initializing the array. I mean, let's pretend we solve it. We make our blocked range default constructible and assignable. From blocked ranges, we have the initializer list of blocked ranges, right?
Okay.
Like, and I mean, this is kind of relaxation that we don't want, but let's pretend we did this. There is a bigger problem to me, even if we do this. I mean, if we imagine that we did this. And it's about size of initializer list.
No way to know where.
No way to what?
No way to know what a compile time.
Exactly. There is no way to know it at compile time. So it's, in principle, this makes this code valid. While here, we explicitly say 3. I mean, of course, we can throw an exception or whatever, or can just swallow it silently, but neither is good answer specifically to me. There is always a feel that we can do better. All right, are we good? Like, we understand why initializer list doesn't work? Okay, the next step was, hey, what about we take std array? I mean, yeah, let's do it properly. Const std array, then we have t, we have n, we have everything. Here, probably I also need to say ref, right? And I mean, it's pretty easy to initialize the array as the field from like one std array from another std array. There is no problem here. It also doesn't work because now we have one object that we need to construct, and it's like std array. So we thought, okay, let's add a pair of parentheses. And yeah, it should be like 3. Nope, still no luck. At that period of time, for some reason, I thought, okay, let's try this. Let's just add one more pair of curly braces. I messed up previously. Curly braces. Done. It just works. And I mean, I can explain it. It's not like magically works. I know specifically why it works. No, it's just specifically the array of blocked range, one-dimensional of t, of int. That's exactly what we want. I mean, we want as the class implementers, but not what users want with these 2 extra curly braces, even before like constructing the objects. So what is std array? Std array is basically, I mean, it's going to be pseudocode. It's not going to be compiled, but in principle, it's like t out of n, right? And it's plain. It doesn't have any constructs. And I mean, let's pretend that we have here, I'm not going to write like type names and std size t. I assume you can imagine that. And this is sort of our struct. So it's like a definition in some pseudo C++. The point is, this curly brace to initialize blocked range in D. This curly brace to initialize as like std array. This is to initialize a C-style array within std array because it's an object. And those are the arguments to specifically blocked ranges. And that's funny because braced elision doesn't work in this case. There is a feature of C++ which called like brace elision. And I never can actually make a sense of the rules how it works. So I'm not going to explain it here for sure. But the thing is, it doesn't work here. We can still achieve what we want. I mean, we can, return back our initialization, comment our default constructor, and I think everything should be okay. No? Oh yeah, because like I have this pseudo array.
Well, and you have 2 sets of braces.
Oh yeah, and I also don't have this. What else? R is not declared.
Your cout pre function is before your.
Oh, I see. Yeah, I have the body, so I need to move. Okay, thanks. So in principle, it should be like this, and this should be removed, right? And one extra, yes. Yeah, so this just should be moved. Sorry, should be moved here and here. Okay. Yeah, I mean, in principle, we can also debug and print what what it's initialized, but believe me, it just works. The problem is the API still doesn't feel nice, right?
You could remove the constructor and just make array public, and that would solve all your problems.
Well, maybe. I haven't thought about that, actually.
I'm almost positive it would.
Maybe we can try this or like offline, whatever time allows. But the point is, like, if we have this curly braces extra, like 2 pairs of initializing std array and then C-style array in std array, let's just try to use C array directly, right? I'm not sure that everybody is familiar with the syntax, but it should be something like that. Sorry, not like that, like that. Remove.
Fire name is in the wrong spot there.
Yes. So it should be like this. And let's comment this for a moment, because now we also don't have a way to initialize std array from C array.
Oh, you have too many braces still?
Let's see, no matching constructor.
No, you have to delete them.
I deleted them. Yeah, I deleted them, and it should actually work. What's wrong? The name is. Sorry.
Is that ampersand? It might be.
It's a reference. It's a const reference to C array.
I was getting syntax wrong personally, so. Anyone else did?
Okay, what? No, I'm pretty sure that syntax is right.
Is it right? Okay, I think it's right too.
Yeah, I also think it's right. So I think it's about invocation.
Or is it because of the T?
Is
You
it?
have an array of T when you actually need to have an array of block range of T?
Yes, exactly. Thank you.
Okay.
Yes. So yeah. Yeah, it works. We now also need, I mean, if we keep our blocked range non-default constructible as we intend, we also need to write a C function, sorry, like some function, some helper, which would just initialize our std array from C array. Sorry?
To array?
I think we don't have such in the standard.
Yeah. 7 out of 17? 20 was added.
20, okay, yeah. It was always the idea to propose it, but actually, I, for some reason, could not find it. Do we really have that? Std to array, right? Oh, okay, cool.
Well, look, the AI says it's there, so it must be.
Oh, okay. Okay, we don't need to write it. We can just use it. But that's, that's not a point here. The point here is like we use C array. By the way, also, I forgot to mention that when we had the constructor itself template one, right? We could not deduce the template parameters of the constructor because with curly braces, it makes it non-deducible context. But now, for some reason, it works. And it works because actually there is no any deduction here. We first said that, let me probably move it down. We don't need it. So at least for now. So we, in principle, already said int and 3. And all the substitution of templates already occurred. So we have like int here, 3 here. We know for sure that t is int, and n is 3. And we know that as well here. It's like the template parameters of the class, not of the constructor. That's why we don't need a deduction here. We need a conversion from braced init list, basically finding a proper constructor that matches to an like C array. That's why it works here when we just use some curly braces. I mean, we were debating a lot on our team. Is it good enough? It's not super convenient, yes, but I mean, we at least eliminated one pair of curly braces, and we thought, okay, is it good enough? Should we try to move further? And the guy who originally was talking about like this API, like nice to have API, said, no, I'm definitely not going to stop. I'm going to Google. I'm going to like understand. And like at that period of time, I didn't know about like template metaprogramming as I know like today, and I could not, invent the solution myself. But then I realized it, improved it somehow. Like he was able to find something that was helpful, not exactly the solution, but something that was helpful. So, what does anybody have an idea what we in principle can do? We have the already the class that already has the template parameters substituted. So in principle, what we really want here is to generate the number of blocked ranges equal the number of n. And we do want those to not, to not basically bring to the API any deduction. We want still the conversion, like the constructor to be found and to be matched. That's what we want. And we're not talking about reflection. I haven't explored it yet. I don't know if it can do like this code anyhow better with reflection. And also like keep in mind our constraints to be like at C++ 11. So it's definitely, there is no reflection in C++ 11. So based on what I just said, where we have these, like what we in principle want, does anybody have any idea how we can do this? Like all this was like sort of easy part of my talk. We're going to fun part. What?
Integer sequence.
Integer sequence is helpful. How are we going to use that? Okay, let's try. Oh.
Moving to the talk of class template argument deduction.
Say it again.
Class template argument deduction.
Class template argument deduction. We're not going there so far. We're going there further, but class template argument deduction here is not what we want, because again, like at least for now, what we want is to have this int and 3 basically saying us what's going to be the type of arguments. So in principle, we already have the information based on the template arguments, and it's going to be even more challenging going a little bit forward to write the deduction guide for such a constructor that we are going to implement, because it's a chicken and egg problem. How we're going to deduce something based on the constructor where we rely on this knowledge to generate this constructor, right? But let's not try to be overwhelmed right now. Let's solve the first problem before moving to the deduction guides. So what we can do in principle is saying that this is our blocked range class. And what I'm going to use is extra template parameter. which I name index sequence. And that's it. As you can see, this class is not defined. It's incomplete type. Then I'm going to say that this is I'm going to use default template argument. So this is index sequence. Std index sequence. Maybe just, to make it visible. Then we will write a partial template specialization where we say that here we have T, then N, then, oh yeah, and sorry, I did the wrong thing. What I need to, okay. Partial specialization that says index, what, okay, I pressed on F12, index sequence with, what, let's call them just IS. And we have those IS here. And we also need a type. And we need to close the angle bracket, yes. And the point is, we have an extra template parameter, and the class is going to exist. I mean, the definition of the class is going to exist only when our third parameter is index sequence. And if it's not, if it's something else, it's just incomplete type. We cannot construct that. So we're going to say make index sequence here out of our n. So we know that.
Dots on the wrong side.
Yes. The errors are weird, by the way. And now we need to somehow use this knowledge. I mean, we have the number of indices, which exactly the number of elements that we want. In other words, we have a parameter pack that contains exactly the number of elements that the number of arguments in the constructor we want. But we, like our blocked range T has type template parameter, while this is our non-type template parameter, or whatever it's like called these modern days, probably constant template parameter. Never mind, so it's not type. So what we're going to use here is, I mean, we can do whatever, but we need like some level of abstraction. Sorry. I don't know why my fingers don't listen to me. We're going to use some template with just individual index, and we're going to use, let's say, template alias. It's not necessarily template alias. It might be the struct that wraps it, and you can read it from there, but why? And we call it archetype, for example, and it's actually blocked range T. We can use T here because we have T here, right? We probably need to use some other name here to not shadow this one. But what we basically did is said, like, we don't care about indices. We don't care about the number of about the values. We just care about what these parameter packs carry to us. And then what we're going to do is basically use this arc type with is ... here, because we want individual archetype, but repeated as many times as we have in our parameter pack. And then we just use, like, what did I call it? Like blocked ranges. and then use R and initialize it with blocked ranges, ... And then, oh, I already have this line. Never mind. And then I'm probably going to remove one extra pair of curly braces and see what I did wrong. Nothing. Surprise to me. It works. And it does exactly what we expect. Do I need to explain something more?
Scroll back up to the
Yes. Yes. Let me remove this. We can also even see what's wrong here, or what's right here. Like we have t int, long unsigned int. Maybe I'll do it like this. And like all the like, but this is the class definition. So it doesn't tell us what archetype is. It just says like long unsigned int. It's our index sequence. It doesn't necessarily have to be index sequence. It can be integer sequence. It can be like any values, but we just need, to be able to generate the number of constructor arguments. Yes, and we have 0, 1, 2, but again, it can be like any values. This is just the easiest way to generate the parameter pack that we want. And here's basically our implementation. We did the constructor. Questions?
Will this deduce if you remove the explicit template parameters?
Where? Oh, you mean here in class?
Yeah, I don't want to specify that.
Oh, of course not. I said like you basically rely on this knowledge to generate the number, like to write a deduction guide that would allow you to use CTAD. You basically need to like it's tricky. I can write one. It's not like fully generic. If somebody knows, like if at the end somebody knows better solution, let me know. I would love to hear that. But the trickiest part is again like we need these template arguments to be able to generate the actual amount of arguments in our constructor. And let's test that it works as we expect, right? So if we just say extra, it doesn't work. If we say less, it also doesn't work. If we use some mix, for example, if we move up one of our blocked ranges, and use, let's say, like BR1 here.
I think that you could, but you need another function. You need like a free function.
For what?
That makes the type. Because then it could count, it could do a size of the argument pack.
How are you going to deduce curly braces again?
I think a deduction guide to do it because you can do size of in the deduction guide.
Yeah.
Yeah, but we are not getting to the deduction guide yet. It's just like in the moment.
So that would be 17.
So, any questions about like this implementation, about this constructor that we implemented? Do I need to explain more, or shall we move further? Oh, right. This is actually a good question. Let's remove it and see if like it still works. And it does. I mean, again, until I messed up, but it does. All right. Any other questions? Move on. Okay. So there is a problem with this interface that we solved this way. Like, what I don't like about this interface is like publicly facing API has this dummy template parameter which in principle can be replaced by the user, but also they're gonna have an error, but it's not like informative. It would say like blocked range ND is incomplete type or something like that. So we can solve it by just saying that this thing is impl as well as this thing, right? And then do some, I don't know, like something like this. And then struct, probably not necessarily struct, we can say using blocked range ND is like blocked range ND impl of T N and basically this thing. And also, like, did I forget? Yes. And also, I don't need the default parameter here anymore, because I mean, we can pretend that this is in namespace detail. And if users use something from namespace detail, that's their problem.
Yeah, I need to,
Yes.
you also need to remove the eyes.
Yes, I need to remove it from here.
Remove its eye.
Yes, remove its eyes. And honestly, I mean, we don't even need n here, right, for the impl, because we can always just calculate it based on the parameter. So let's do this. So remove n, and also remove n here, and remove n here, and say something like, I don't know, static const expr auto n, which is equal size of what? Size of dot. Yes, exactly. So you're still following, cool. And I think, yeah, it like still works, and we don't actually need this. Size n on line. Yes, because I need to make index sequence to fill out my parameter pack. Again, like, this is good solution to me, but I didn't want to stop there. I started to investigate how we can write a like deduction guide. At least some, like for the user convenience. And by the way, let's check that this before we get to C++, before we get to deduction guides. Let's check if this code still works with C++14. Yes, it does. Cool. So, but I did want that deduction guides, if let's say we invent some of those, would work from C++17, not from C++20 or like further down. So of course, like for C++11 and C++14, you don't have any CTAD. But if users use C++17 already, why shouldn't we give them some usefulness of this feature? What is completely broken here to make it work in C++17? Deduction guide do not work with type aliases in C++17.
Right.
And with plain, I mean with struct, without like constructors and with all of that. That's fixed in C++20, but in C++17, it's not. So we can fix that, at least as our first step to make it work. So it's not like alias anymore. It's our like class or struct or whatever. Let's just write it. And use inheritance instead of everything that we used previously. But also the problem is we need to somehow to bring this magic that we did here in our derived class now, right? So does anybody know the syntax how we do this? Yep, we just make the name visible. What I'm gonna do is basically say that our base type is this one. And then I'm going to use base type. No, I didn't make a mistake. So yeah, this syntax basically for somebody who doesn't know that probably just makes the constructor of the base classes or class like visible in your derived class, and basically give it like a proper name, pretend it's like would be calling to this constructor, and then it knows where to redirect it if constructor matches. Basically making this name specifically visible in this class. So we did our first step to make actually deduction guides. Then we need to write those. As I explained, I at least tried to explain previously, there is a chicken and egg problem. We rely here on knowing the number of arguments that we need to generate based on this value. That's what one we rely. On the other hand, for deduction guides, we need to do something like this, right? And somehow know that we should deduce it like a 3 and int. So this is our chicken and egg problem. There is a solution for that. Again, as I said, not fully generic. I don't know how to make it like fully generic. At least probably again reflection can help, but have no idea so far. But still, I think like perhaps good enough one. So what, like any ideas? Can anybody guess what we're gonna do? Okay, to answer this question, let's first, like the deduction guide looks like a separate function. So it's going to be something like this, right? So we need to deduce something, and we're going to take something as well. So let's for now just write this, and then this. And then let's not focus about deduction guides at all. Let's just pretend that we have some function foo, probably even with body, and we need some sort of argument that can deduce both t and n for us. But specifically deduce. We already know that if we write something like blocked range t, right? And I mean, the obvious thing is it doesn't deduce n. It doesn't have such a parameter. But this is a separate function. Like this t is not even if it's a deduction guide, this t is not somehow correlate to this t, and it's needed to be deduced individually for this function, right? And if we just say something like foo, and even like, you know, to avoid this confusion, just pretend for a moment that we know how to deduce t, but we say foo, and then again this thing to try to construct blocked range, we have the same problem we started from. It's non-deducible context. It doesn't know how to infer this t from this. Of course, if we just say like br1 or how did we call it? Yes, BR1. It should work, I hope, yes. So because T now is completely deducible, it's blocked range, and this is blocked range. It knows the type, it knows exactly how to infer T, and again, we pretended that we know how to basically deduce this N. So, but we want still to be able to do this. What could help us to make braced init list as deducible context? Except initializer list. Because again, initializer list doesn't know the size at compile time. Does anybody know? We can use C array. On CPP reference, there is a block, some part of it that tells about deduction, and it specifically tells to which types braced init list becomes the deducible context. Like from that, if I remember this list correctly, the only thing that can help us is this C array, C-style array. So we're going to use this just to check that it works before even writing a deduction guide. And we also don't need this anymore, right? And we need to do this. Yes, it does work. And we're also going to move our pretty function here. Sorry, I'll do this and then move. So we can see what it says, but I'm pretty sure it should say exactly what we expect. So with T int and unsigned N equal 2. Again, here int is fine because we call it with just these arguments. We're not calling it like with blocked range. We just say some T and some N. We have two integers. That's why the size is 2, and this is the array of T. That's how we deduce it. But then how we can use this to make our deduction guide. When I first read about parameter packs and the context where parameter packs can be used, I found some example on CPP reference which tells me about the syntax that would allow the parameter pack of C arrays. And I was, whom in the hell can this be useful? And it turns out that it's exactly what we're going to use here. Now I need to remember the syntax of deduction guides. So we need to do something like this, right? And say blocked range ND, like something. So I need to remove that, of course, and I need to make like plenty of tweaks. So first of all, we're gonna say that we have this. Sorry. And we're gonna have this, and we're gonna have this. And then what we can do is to say size of NS. And foo, of course, is not declared, but who cares? And let's check if it works, actually. Maybe not. It does. So, and let's check that, I'm not tricking you. The method that I usually use is like, there are several, but what I usually use is struct print, which is not defined, and then I say print decal type br2, and then define the variable. Of course, it's a compile time error because I cannot construct something which is undefined, but that's not the point. We can see exactly the type that we deduced. So int and 3. That's what we want, actually. Also, if we change this, for example, to this, right? We're going to see int and 2. I mean, and if we add more, you can guess that we can see something else, like 4 or whatever. We can also try to change some type. I mean, let's make it unsigned.
What does the error look like if one of those arrays is not an unsigned array? Like, just change the last one so it's 1 and 2 instead of 1 U 2 U.
Yeah, that's one of the limitations.
I just wanna see the error.
Yes, but it's like terrible.
Yeah.
So it's like class template argument deduction failed.
Yeah.
This is not the only limitation, by the way. So if we start talking about like, and then some, some stuff that not pleasant to read at all. So let's talk about limitations. First of all, I don't know why it's designed this way. I probably should ask my team. But it's like, as you can see, T, and grain size is always size T. So it's going to work fine as long as all the... We basically did not do that yet, by the way. And probably we should. We did not check that all... Oh, sorry, no. This implies by this syntax. How I implemented it previously was like this. And I mean, of course, it needs some tweaks. But basically, those are 2 parameter packs that are wrapped in like one expression. But now we changed that all T's are the same automatically without writing any constraints or whatever based on T. What we still need to write is the constraint that our NS are either 2 or 3, right? Because that's exactly the number of arguments that blocked range itself can take. So if it's like 4 here, okay, let me remove this use and then add like more arguments. I think the deduction guide would work, but then the constructor wouldn't. Yeah, no matching function to call. So the error changed. So
You have to put that in all 3 of the arguments.
No, he has 3, 2, 2 right now, and it's working.
yeah, it's working. It just yeah. So we can write it later, like just for the sake of completeness. And probably I'm gonna. Oh yeah, this is deduction guide. I have C++17, so I'm just gonna use fold expressions. So this is, I mean, in the real library, you can imagine that it's just, surrounded by macro if C++17 like is available or whatever. There is no CTAD. There is no this syntax before C++17 anyway. So yeah, this is sort of one limitation, that all the types should be the same. Otherwise, it doesn't work. Because it's like arrays, and we all explicitly say that those arrays are like have the same type. Otherwise, if those are different type, we could in principle do like this, as I wrote, with some tweaks. But the point is, if those are different, we have only one. Sorry, here we have only one type of blocked range. So we need to deduce one. And if those are different, how we can like determine what users mean? Which type did they want? We have no idea. So let's go back to this. And the second limitation is this is C array. So it would only work for this expression. But if, let's say, we would use we use BR1 here, it doesn't work because BR is not anyhow convertible to C array. I mean, I honestly don't know what we do today in TBB. Maybe we just have a separate overload for blocked ranges where all of those are known to be like blocked ranges. But those are like limitations that either all of those are blocked ranges or all of those are like some braced init list that we further figure out that those are blocked ranges. Maybe those limitations are not clear enough because we did not talk why this works in principle. Why this some weird C arrays parameter pack eventually does what we need and then matches the constructor. Can somebody but me explain it? So this is actually the interesting trick to have in your sleeve, because that's how I basically partially solved the chicken and egg problem. The thing is, the deduction guide doesn't have to, strictly follow what's written in your constructor. It can do something completely different because how actually deduction guide work, they like if you didn't specify any like template, wrong one, template arguments, what's going to happen is first, class cannot be constructed because the template is not instantiated. We don't have any type. We only have template. And we try to understand how to instantiate this class based on the arguments of our constructor. Either compiler can figure out it by itself if it's simple, if there is a direct connection between like these types and if those are used in the constructor. But here we have something tricky. And furthermore, like with inheritance, so what happens actually is the deduction guide applied first. Then, if it found the deduction guide, like basically it works pretty much like overload resolution. If it finds a suitable deduction guide, I mean compiler, it deduces the types from this deduction guide and has the template with the arguments. That's exactly what happens here, right? We have braced init list. We have like 3 braced init lists. Those are like arrays, basically converted to 3 arrays, to be precise. Then we have this T, and then we have size of. Now we have the arguments to pass to the class template, and that's exactly what we do. Then all of these things like instantiated, the substitution appears, and then it tries to find the match to the constructor. The arguments, this is important, are still the same. But here we use the trick with C array to actually understand what template arguments we have. And then, since we already have all of this machinery, we generated the number of blocked range that we wanted. And we already know that this syntax matches to this constructor. That's how it works. Clear? I hope it is. Like I did my best.
Question.
Yes, sure.
remember if I've ever tried this. Could you change the deduction guide so it actually deduces the impl and you could skip the actual implementation of the MD?
You mean
Right
just
there,
here?
yeah.
No. Some compilers swallow it, I mean compile, but it's not according to the standard.
Okay.
We faced with this, I mean, probably it's changed it in some like more modern standards like C++ 23 or going to change in C++ 26. I don't know. Yeah, probably not. But we faced with this issue on some other class. And we were, okay, GCC compiles, Clang doesn't. And we just, who is right? And we figure out that it should be exactly, we had some, you know, metaprogramming type. So like some wrapper that eventually does something, but there is some line in the standard that says like it should be exactly like this. Again, maybe this limitation can be overcome and like standardized to be broader, but that's not what's in the standard to the best of my knowledge. Other questions? Do I need? Oh yeah, go ahead.
The grain size in the core block range. Should that be the same between all of the like block range, like the dimensional block ranges?
What do you mean? Like where?
In like struct block range.
Is it a constraint that when you have an n-dimensional block range set, that all of the block ranges inside it have the same grain size?
The same grain size? You mean value?
Yeah. Same.
I don't think so.
Because it makes the problem, if you make that a NTTP on block range, it makes the problem a little more interesting still.
Why should I? It's runtime value.
Sure, but if it were a compile time value and they had to be identical, because then you could constrain on that, like all of those being identical.
Okay.
It doesn't actually execute any code at runtime.
Okay.
You get another layer of funness to the stuff we're doing here.
Yeah, I mean, maybe interesting, but not practical for us.
Yeah, you might want to specialize if they are the same because markers are not.
Yeah.
Maybe. I mean, you can imagine that 4-dimensional problems in parallel worlds are already not that common. So we don't have a lot of requests, but we do have like real customers who just recently reached us and say, hey, can you just add one more constructor? I mean, not that crazy as this one is, but the simple one. But still, they asked for some convenience, so that basically proves that this API is used. Though I've never heard probably about like somebody saying and coming and saying, hey, how we can parallelize 5-dimensional problem with TBB parallel 4.
All right. Okay.
And I mean, it doesn't mean that those problems don't exist. I'm just saying nobody came.
I said interesting because the physicists that I work with are like, oh yeah, we do lots of 6-dimensional math.
Okay.
I'm surprised no one is asked for greater than 4.
Parallelization algorithm
Might not be appropriate. Well, no.
I mean,
they're definitely
yeah, I mean, if you have enough size in every single dimension that you use, and it's like independent, all iterations are independent and touch independent. Yeah, so I mean, in principle, they probably don't know that such APIs exist or whatever. It's, again, like not the problem that doesn't exist in industry. I'm just saying, like, we only heard the requests about like 4, I think. I might be wrong because I didn't pay attention to TBB for like several years, focusing on 1DPL more on parallel algorithms, but still. What else? Like we covered limitations, we covered how it works. We did not write the constraint in C++ 17. So let's do this. I think it's going to be enable if t, then what? Then trying to do something like this. Size of sorry, dot 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 ns, and then and then dot dot dot, and then again this, and then we should say ns equal to or yeah, ns, it's pretty ugly to write, honestly. Ns equal 3. I really need to find this setting on Godbolt which disables putting the parentheses for me.
You can right click and say.
Oh, okay, cool.
I never have, I also just complain about it.
So what, okay, so and now how actually I'm going to write this enable if. So if I am not mistaken with number of parentheses and curly braces, that should be like this, and if I did, then it's going to be disaster. Okay, whew, thanks God. Yeah, I mean, basically we use fold expression, and actually something that not usually I see in the code, we use this init expression in fold expression. Then we say, hey, this should be, and yeah, I should probably make it clear. So what I mean, it should be greater than 0. And then we say, and like for each ns in this parameter pack, this is like 2 or 3. If it's not, then like this deduction guide is all formed. This is the substitution failure. And if yes, like we have a type int. So as you can see, I used like std enable if, and if it like works as expected, like I mean the first expression is true, we're gonna have int type here, and I'm just saying that my dummy int argument equal to 0. That's it. I mean, there are different ways how to write enable if. I could potentially just do something like type name even without name, and remove this last part and not even say that this is int. I could be happy just with void, and I hope I also didn't mess up with like parentheses. Yes, but that's not the preferred way to write enable if to me. I can chat offline why. So did I forget to cover something? I actually don't think so.
What's the first constraint to the enable if the greater than 0? Just that you must have at least, it must be at least
One.
At least one like dimension.
Yes.
Okay.
Well, this deduction guide would never get found if it didn't.
So something I'm curious about. So in your example, you've got t as int, and then you've got size t as the grain size.
Yeah.
Yeah.
In an example where you pass a grain size as int, and it's unsigned, that's fine. But if the compiler is going to warn on that,
Is it
treat that as
fine?
I think practically speaking, it's fine, but if your compiler's going to warn on it, you have that warning on it.
No, well,
Warning says errors. Then
I don't think you'll ever convince a compiler to warn on that particular situation.
I sort of think that probably it's the size t to always be unsigned, in the sense that t can still be signed.
Yeah, but his point's there.
I understand. Yes, I understand. Yeah.
I think it's difficult to get a compiler to warn on this. Because it's a literal in this syntax. In this case, it's a literal anyhow.
Okay, I
That's,
was just curious if there's any way, if that were a problem, how could you address this in the interface. It seems like you want to use that.
I'm still going back to the fact that if you just made R public, you could remove all this magic.
Maybe. I mean, the deduction guide wouldn't work in C++17.
You don't need the deduction guide.
Why?
Because
In C++17, it doesn't work with, I mean, for std array, we had a deduction guide in C++17 because it doesn't work for constructor. No, I mean, for structs, we don't have it before 20 until we write it explicitly for structs without constructors. Yeah.
Yeah, if you had 17, you would see you could still use the deduction guide, make R public. I think you might still fall back to having to have an extra set of braces though on Clang, but not on GCC.
Oh yeah, like we might end up with the problem of this brace elision that I showed with my argument. We probably would need to initialize public struct, then this R, which is internal, and then like blocked ranges. And maybe it would work, maybe not. I need to experiment with this offline. But that's at least an interesting idea. Any other questions?
I gotta ask the question that reveals that I lost track a while ago. Does this require that T is convertible to size T? This deduction guide on 49.
No?
Yes,
So if
only if there's 3 parameters.
if you have a third parameter and your T is not convertible to size T, then
If you have 3 and if you have 2?
If 2, then it doesn't.
if you have 2, it's fine. But if you have a third one, you try to pass to I don't know what as your first 2 arguments.
Floats.
Yeah, I mean for sure if you have 3, yes, because otherwise, I mean the array should contain like only the same types, and you need to be able to pass like the third argument as the third argument of this braced in, at least the third argument of blocked range. In that case, yes, but if 2, then no, which means that it's not strictly required, but it's required for 3.
Right.
Yeah.
Can you do me a favor, please?
Yeah.
And try.
It seems like to get around that, you could add it. So you have a constraint that takes an array, and the vector guide takes an array. But you take a second optional parameter that's a size T, alt it to 1, and then you can have any T that doesn't reduce to sorry, it doesn't convert to size T, and then you have size T.
But that implies that all the, if I understood this correctly, that implies that grain size is the same for all blocked ranges within blocked range ND.
Well, that's not what I intended. So,
But I mean that's the outcome. No, if you just take one that size. Remember, we need some arguments that would match both deduction guide and then constructor.
So if you did, can you add another set somewhere? A new, whatever, one of your examples down there. And you had shown that you can do like use in one of them. Would you mind doing one that's just a single value with a pair of like 2 doubles in it, right? You know what I'm trying to say? So like your whole thing is just 1.0 comma 2.0.
So like, sorry. And by the way, I'm not sure that I understood correctly your, like one of your previous comments, Jason, but when you say like it's literals, those don't have necessarily to be literals.
Yeah, I
Those,
know, at the moment they are. That's
okay.
whereas-
Oh, you say that's why we don't see like any.
Fine.
Yes.
But the moment you add a third parameter to it.
Oh, you're just thinking about narrow conversion and.
Yes, narrowing conversion because it's braces. It will.
Yeah.
I just
Yeah.
verified that.
Yeah.
Because you never allow narrowing conversion in braces.
Yes.
which I like, which is a problem with C++20 is parenthesized init.
Yeah. So of course this.
It always comes up with students, because I show them, I'm like, oh, and by the way, C++20 added the syntax, which helps with these situations, but also breaks your assumptions here. And students are always like, oh.
What do they expect?
Yeah.
So let's go back to the talk for a moment and probably wrap it up. I don't remember that I wanted to cover anything else. So first of all, any more questions on that?
I have something real quick. If you didn't have the constraint of C++11, would you be able to rewrite this without using index sequence? Have you thought about it?
I mean, index sequence is part of C++11.
Like if you didn't have a constraint, so if you could use C++20 or
Oh. Again, maybe a reflection, but I didn't do my homework yet to understand whether reflection is helpful for this particular case. Maybe it is. Maybe I'll just ask some people on the upcoming C++ committee. Except this, I mean, I could use something that fills the parameter pack for me, but not index sequence. But the idea would be the same. I need the number of template arguments in parameter pack, which basically equal to number of n. I have no idea how to make it differently. What's wrong with index sequence, if anything? Oh, you're just curious. Okay.
I find it's a little verbose, and then you start adding stuff like we just did.
Okay.
It used to be very slow to compile, but now the compilers out of it.
And if intrinsics are not available, they have logarithmic implementation anyway. For example, Clan does logarithm of 8, I think, or something, not even 2. So.
Would you be able to share the code maybe on the Discord or something? Like the link to.
For some amount of money, yes, of course.
Just do share short.
Yeah, I mean, I'll do it probably offline. I hope I'll just click it to. I mean, I'm not connected to Discord right now, but I click it to not.
Just take a picture. Right
Oh,
there. You've got
sure.
like 10 characters on the URL.
Right there.
Yeah, but I can also share it like in the Discord, and clicking on share button is wise because if I close this window, it might be lost. But now it's like.
Oh, you do have a history even if you close the window, just so you know.
Okay.
Under like more on the drop down. History.
Click on it if you have.
Yeah.
stuff.
I'll try it offline. It. Yeah, I mean, if it's even if it has some Intel stuff, I mean, I only use this Godbolt for public stuff, so it's not something. Yeah. Okay, are we done, or any more questions that I need to explain? Then the question to you: was it interesting? Was it useful? Was it?
Yes and yes.
Okay. Do you want more talks like this?
Successfully, you're going to be with getting more people to do this much live coding. But yeah,
That is a point though. We don't currently have anyone signed up for November. Who wants to volunteer?
I could, but again, Kona.
Anyone?
is the lightning talks reserved for December? I thought it was November and or December.
It's, yeah. I don't know. Yes, it's something. Well, okay, let's do this. Let's thank our speaker today.
Thank you. Thank you all for coming.